Alright, welcome to part 8 of my ActionScript 3 platformer tutorial. Today we're going to do a little bit with particle physics, and in doing this I'm going to show you guys a little bit of what the graphics will be in the final result. I don't want to get quite to the point where we have all of our graphics done yet, because I want the people who are using just Flash Develop and don't have Adobe Flash to still be able to follow along, and then once we get to the end I'll show those of you who do have Adobe Flash how you can make your graphics of your own in Adobe Flash. And then for those of you who don't have Flash and just have Flash Develop, I'll show you guys how we can get graphics from Flash and put them in Flash Develop, and I'll have links to the graphics that I have made, and then you guys can just use those. Alright, so what we're going to do, while I was talking, I made a new class. It's going to be the particle class. And right now what I'm doing, we're going to give it some graphics. It's just going to be a yellow rectangle. And what we want to do, we have like our first line that we always do. And I got rid of all of the other filler. But in our particle constructor, we want to say size int. So it's going to take in the size. And we're going to have x minus size divided by 2 for the starting x coordinate, y minus size divided by 2 for the starting y coordinate, and then size and size for the width and height. Basically, we're going to be able to give this a value, and it's going to make a square of that size wherever we want to, and fill. So that's that for now. We could go ahead and we can add a few more variables in here. We're going to have public var x speed and equals 0, public var y speed equals 0, and public var r speed is 0. So that's the beginning of that. And then down here we're going to make a function. We're going to call it update. This is going to be just like a check stuff function that's going to be just in the particle class, something that we can run every frame. And we're going to say x plus equals x speed, y minus equals x speed, y speed, because you know it goes from top to bottom rather than bottom to top like it does in math, so we got to have it kind of the reverse of how you would think of it. And then our rotation plus equals r speed. Now we're going to go back into our main class, and we are going to add an array up here with all of our other arrays. Private var, we're going to call it particles. Just make it an empty array. Then we're going to scroll down a little bit, and what I'm going to do up here with our mouse down function, I'm going to make another function, and I'm going to call it make particles. And we're going to have the arguments, we're going to be one for the number of particles we want to make. We're going to have one for the x position, the y position, the x speed, and the y speed. First thing, we're going to make a for loop to go through, int 0, to go through every individual part as many times as we need to based on what number num is. And in here, we're going to first say var particle equals new particle. We're going to give it a random size. It's going to be math uppercase m dot random open close parentheses times, we're going to say 10 plus 5. So basically what this does, math.random gives us a random number from 0 to 1. It's going to be a whole bunch of decimals. Times 10, that gives it any number from 1 to 10. And then add the 5, we're going to have any number from 5 to 15 for the size of our particle. And I'm going to put this math.random in a math.round, just so that we don't have funky values that are going to take longer to calculate. Next, we're going to say part.x equals x pose, part.y equals y pose, part.x speed equals x speed, part.y speed equals y speed, part.r speed. We're going to do another random. It's going to be math.random. Again, we're going to make it times 10, and I'm going to say plus 20 because we want this to be pretty fast. And now with our x speed and our y speed, we don't want it to just be always at the same x speed and y speed because that would be very boring. So what we're going to do is we're going to add just a little bit of variance in it. We're going to say plus math.random times 10 minus 5. What this does is it gives us any number from -5 to 5, because think about it, if you had, this is from 0 to 10, so that 0 to 10 shifted down 5, it's going to be -5 to 5, so it's going to be within a 5 pixel distance of the original speed, and then this is going to be within a 5 pixel distance of the original speed here. We might make that a bit wider of a gap depending on how we want this to look, how it looks at the end, but for now that's going to be good. And then we're going to, at the end here, say cam dot remove child part, no, add child, what am I thinking? And then particles dot push part. So now we're going to have that for however many we want. And up here in our m down function for when we shoot a bullet, we're going to have, put it right here, make particles 20. The x position can just be the character position, same with the y, and the x speed will just be x speed, and the y speed will be y speed. And then down here we're going to want to put in the rest of our for loops, one for our particles. We'll give it p for particle. And then we're going to say particles p dot update, and then that should be good for now. Let's see, is there anything else? Oh yeah, in here I'm going to at the end put y speed minus minus. What that's going to do is that's going to simulate gravity on our particles so that when they are falling and moving at whatever speed they're moving at, they'll still be falling. So looks like, alright, this should be plus speed, because that didn't quite work how I wanted it to. So now we run this and we get these particles that it looks like they're really just following the bullet. So what we want to do is we want to actually take this x speed and this y speed, we want to take those both and divide them by 10 so that it's not going nearly as fast, because we don't want this to just follow the bullet, we want it to just be near the gun when it shoots. So now, oh, put that in bullet instead of particle. Let's run this again. Oh, gravity's going the wrong way. There we go. I was a bit thrown off. It probably doesn't look too good just on the video, but if you actually run this, the effect does look pretty cool. One thing that I'm noticing is that it always stays, yeah, it always stays on the right. We got to change that. So in order to fix that, all we really have to do, I should have caught this before, we got to make particles under this thing where we flip the direction if necessary. So now we go ahead and run this, and now our nice little particles follow no matter where we go. Alright, so now what we want to do is we want to make it so that after a certain amount of time the particles go away, because we're going to have a lot of lag if there's just all of those particles gathered at the bottom of the screen falling infinitely. So what we want to do is put in here alpha minus equals 0.0325. 3125, excuse me. What this does is the alpha is a property on a movie clip. I can put up this little description thing here where it's any value between 0 and 1. 0 is fully transparent, 1 is fully opaque. So if you have an alpha of 1, that means the object is entirely there, and then anything in between that, it's like faded in or out. So if we put this, subtract a little bit off of it every frame, that means it's going to be fading out. And then once we hit a certain point where it hits 0, we want to go back in our main class and we will get rid of that. So we go down to our for loop where all of our particles are, and what I'm actually going to do is we're going to take this and we're going to put it in reverse order like we did with coins, and we're going to do the -1, p is actually greater than or less equal to 0, p minus minus, and then underneath the update we say if particles p dot alpha is equal to 0, particles dot splice p1, and above that cam dot remove child particles p. So now we run this and they only stick around for a little bit and then they fade away. Really, one thing I think we could do to make this a little better, we don't have to make this go quite as fast. We can make this just 0.25 instead of just plus plus. And one thing we could do is, instead of actually fading them out, I'm going to do something. We'll add a timer plus plus, public var timer int equals 0. And now instead of alpha being 0, we'll say if timer equals 30. Okay, that didn't quite work like I wanted it to. Let's make the timer 10. Alright, gravity's going way too slow now. Let's go 0.5. Still a little weird. Maybe if we just get rid of this altogether. I've got another idea. We can give this instead, like a lot of the times when you're doing particle effects like this, a lot of it's just tweaking based on what you want it to look like. So the last thing I'm going to do to these is I'm going to make it so that we don't actually do divided by 10. Let's do divided by 5. And in the particle, we will go y speed minus equals 0.5, and then if x speed is greater than 0, x speed minus equals 0.5, else x speed plus equals 0.5. So really you can just play around with these values until it looks good to you. Like, I'm probably going to fiddle with this more, but I don't have much time left, so I'm just going to leave it here. You can play around with all of these values, the speed values and everything, until you get it to a setting that you think looks good. Alright, I'll see you guys next time.